Beautiful. Okay, guys, I'm here right now because it's a testing talk. I'm going to talk to you all about testing reactive code for RxJava. Now, who here knows what RxJava is? About half the audience. Okay, so very quickly, I'm going to explain just a real brief overview of what RxJava is in like a minute. So the thing about RxJava is it allows you to handle all the events that happen in your program as a stream of events over time. It means suddenly, instead of having your code where you have callbacks within callbacks within callbacks, all of them with state variables to keep track of where you are in the code and handle it. Instead of having all those callbacks and all those opportunities for race conditions and opportunities to have the wrong state saved in your variables, RxJava handles it by chaining together functions so that your output is a function of your input. It's actually functional programming within Java, but done in a way that doesn't scare people. Like you probably knew when your college professor showed you like Haskell or something. Or Scheme or Lisp. I'm not showing you the screen up there, so I have to, where's the, let's see if I get the right input. Maybe. I think that'll do the ticket. Yep, there we go. Okay, so I'm going to show you how to test RxJava code. Now, this is a very hot topic because largely people don't know how to test RxJava code. And they provide lots of facilities that have actually been there in languages like rx.net for several years now. But they've been changing, there's new concepts, and they're not well explained on the internet so far. So I'm trying to get across some really basic examples of testing. First example here is trying to be as simple as possible with, I actually borrowed this one off Stack Overflow because I just wanted to get started with something and work down to something more complicated and exciting than the simple basic stuff. So test scheduler allows you to provide a scheduler. Now schedulers in RxJava are how you do multitasking. It's how you send jobs to a particular thread. It handles all of that part so that you can just concentrate on your code, and the scheduler takes care of like which thread pool to send things to for a particular segment of your code. So here, the test scheduler is filling the place of the scheduler that might be a thread pool normally. And it allows us to have more control over our code when we're writing a test. In this case, we're using the observable interval, which every second is going to produce a value. We're only taking the first 5, and every second it's going to add the current value along there. So it'll advance by 1 each second until it reaches 5, and then it'll stop taking advance because I said only take the first 5 of them. In functional format, you see the periods, like the builder pattern, are actually a method chain where you can chain together as many functions as you want to manipulate the final values you subscribe to at the end of your observable. So in this case, we're testing observable interval. We're asserting that it's going to equal 2 after 2 seconds and 5 after 10 seconds because it'll stop taking values after 5. And that one will turn out to be true. Let's take a look at something a little more complicated. Well, not quite. Blocking observables is one way a lot of people have been testing so far. I don't feel like it exactly allows you to keep your Rx logic the same as what you wrote. So I even don't know, and this is a good question for Dan. If you have a connectable observable, will it even let you convert it to blocking right away? He doesn't know either, so I'm not the only one who doesn't know. Here's the point. It doesn't look like your Rx code exactly, and you can see it's instead of returning an observable, it's actually returning the type as a list in this case. And I had to convert it to a list, the events. So because of that, because it's not really your Rx code, I don't feel that's exactly testing your code per se. It's kind of like you're finding a way around testing the exact logic you wrote yourself. But it's simple, and you can see exactly what's happening there. I'm expecting an array of as lists, 1, 2, 3, 4, 5, as each event occurring in this observable from 1 to 5. I could have taken any number, but I took only the first 5 events, which there happened to be anyways, which is a no-op in this case. It means nothing happened. right there. That's a totally worthless operator. Anyways, I assert that they're equal, and they're going to turn out to be equal because the blocking observable will decide they're equal. Here's the really interesting test, and this is the one I actually, believe it or not, I did about half a dozen examples in my first talk in Boston last week, and about 17 examples in my second talk, and the only time any example went badly was my test scheduler example, which I changed since I gave my talk last week. So just giving you guys an idea, the documentation was so poor initially that I kind of had to, well, I made a dumb mistake. I'll tell you what it was in a second because it's actually good for you guys to learn from my mistakes. Okay, so we have a test scheduler, a test subscriber, and a worker. And these three things together is going to allow us to, step by step through time, dictate at each moment when we want an event to occur, how far we want to advance time, and when we watch it, what we want to assert on to see what the values were. And so the worker allows us to control time and control when events occur. The scheduler, let's see if I get this right. Well, yeah, all these things kind of fit together in this piece, but here's the thing. I want to be able to test retrofit code. Retrofit is the networking library that people love on Android these days. And it returns observables for ArcJava because it's so easy to work with observables when you're trying to chain events and keep your state in a beautiful shape where it won't go badly. So what I did was I made something called a publish subject. A subject is something that, unlike an observable, allows both input and output outside of the initial creation of the objects. So because we can do input as well as the output you would normally do, we can actually push events into our publish subjects as if it were, basically just pumping events out by using the worker. So here you see worker.schedule, I'm actually pushing an event, a network response, onto my subject at 1,000 milliseconds. And a bit later I say worker schedule, I schedule another event, and then on completed at 2,000 milliseconds. So keep in mind, the order of these doesn't matter. I could have swapped them. They would have still occurred at the same amount of time. The one that says 2,000 would occur later than the 1,000. That's irrelevant. The mistake I made was I advanced time before I subscribed. So I had a live demo fail because I subscribed too late and it didn't get any events. And I'm like, what the heck's going on with my code? Well, it did exactly what it should have done in that situation. It advanced time. It said, well, there's no events because you've already went past the 2,000 milliseconds. And then it just, politely failed. So, or failed to fail in this case because I had expecting a failure. One thing to note here is that in order, let's see. So the subscriber here allows us to do assertions on Rx observables, which is amazing because people don't know that this exists, to be honest. I'd say 90% of the population using it. So after we've advanced time, say 1500 milliseconds here, we're going to assert that we received a network response 401 because that's what we sent and we want this to pass the first time. And we can make it fail very easily. Then we advance time another 500 milliseconds. The wait terminal event, by the way, if you try to call this before you've advanced time far enough, and it doesn't get either a non-completed or on error, it will hang your program indefinitely or test indefinitely, which can be kind of irritating. So you only want to do that if you know you're going to likely get one of the two. So here we assert that we got the two responses, and then finally we can assert no errors. We've got two responses in total, or two values in total as events, and that we successfully unsubscribed. So what you're seeing here is by setting a special scheduler, a special subscriber, we can test observable logic, and if we set a subject, we can pass any value into that subject that we want to. So anything I put between network subject and those subscribe unsubscribe there can be tested independently of having access to a network and retrofit. Does that make sense? Cool. Okay, so I have one more thing here, last example. This one is just testing, anomaly in this case, it's important to note that if you assert an error, you probably want to use the class and not just say new timeout exception because they won't match. Two objects in Java don't match unless they're absolutely the same object, which makes it difficult unless you write your own equals method, which I had to do with network response down here because we want them to match. There you go. Here's a nice, well-behaved equals method following best practices. Okay, so this one's going to generate an error, and because it generates an error, it will unsubscribe, and this will work successfully because I advanced time after I subscribed correctly. And when I get down here, I'm going to pop up a terminal, two windows, terminal, and I will say Gradle test. And this will successfully work, and I said that in Boston, so let's not make a fool of myself. There, successful. Now, the next question on everyone's mind is, how do you make this thing fail? And it shouldn't be too hard. Just to show you that this test actually tests something, I can do crazy things. I can say, take one on this, so it only gets a single event. Let's do that. Let's do it like that, so it looks pretty. Okay, this one should fail. So I'm taking the first event of the two. Here's the fail. I kind of wish it gave better errors in this, but I think you can actually, it tells you which line number the assertion failed. And each line number actually failed. So this allows you to actually test your Rx events. You can go kind of nuts with this. As you can see here, the code is actually allowing me to essentially do crazy things like test race conditions I might have in my code. I can test subscribing late. I can test, pumping any value I want in there. It doesn't have to be a real, legitimate, number or string or anything like that. I can go crazy with it. Does anyone have any questions about this? It'll be, I don't know, go ahead. All right, wow. Okay, cool. Let's see. So anyway, one point I want to get across is the subject here allows you to inject values into where you would normally have had the observable from RxJava. One of the crazy things about RxJava is that you end up having so much of a chain that it can be difficult on people sometimes, and passing in those values as the subject then gives you that control. Right? I think I said that already. Okay. So yeah, if you guys want to see the examples and go on my GitHub, I actually have a lot more detail on RxJava. Let's see, I can open, where is my slides from the day? I'll just go straight to the slide deck. There we go, screen. There you go. That's where my examples are on GitHub. So you can read all the RxJava stuff and learn a whole bunch. I could point you at slides too if you look at my Twitter, which is Colin Emily right there. And yeah, I had a great talk in Boston. I talked for 2.5 hours, which was crazy, but apparently it went really well, I think. Except for one demo fail, which I learned from my mistake. Cool. How's everyone doing? How do you guys like this Vidku space? Is this awesome?
Yeah.
Sweet, sweet. Yeah. We're enjoying it here too. And so I'm Colin Lee. I make Android here along with Kevin Maturi, who presented last, and also Nate Reuger, who's here as well, or may have left. I don't know at this point. Yeah. So thanks, guys. We're Vidku, and have a great night. I'll pass it over to Lloyd here.
Oh, I don't have anything really else to add. Any questions for the group or any other things? We'll just shut it down.
Right.
All right. Thanks everybody for coming. We'll see you at the next gathering.
Thanks a lot, guys.
We need to roll up.